Hey, what's going on, guys? It's Ellie here. I do coding stuff on YouTube. Check the description for all my information. Make sure you subscribe to the channel. Give me a big thumbs up to support it as well. I do LeetCode problems. This is another one. Lots of people like this problem. I like this problem as well. This is called happy number. Write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. And repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which doesn't include 1. Those numbers for this process ends in 1 are happy numbers. Return true if n is a happy number and false if not. So just look at this example. There is like a 19, right? So we just return true because we take the first digit and we just, kind of like multiply by itself, and we take the second one, 9, and multiply by itself as well, and we just add up these numbers and we get the result. Then we do it again. We take like 8 and multiply by itself, plus 2 multiply by itself, and add up these numbers, add up these numbers, and we do it again till like 1, like just what I'm saying. And but we can have a loop, and we need to overcome it. We need to overcome loop a loop, I mean endlessly, like which goes endlessly. And to do that, we can use two approaches. The first one will be will have time complexity. I mean, yeah, like just let's better talk about space complexity, because I mean, in this solution there are like two, like I'll show you two different solutions, and these different solutions will have different space complexity. So let's talk about space complexity. The space complexity for this solution will be big of n. We will use set to prevent to overcome a loop which goes endlessly, So let's start. Just say set, yeah, as I said, like we use set integer, set new hash set integer, and then we say while n is not 1, we check if set dot contains n, then we return false. Otherwise we say n we need to put an element into our set. So we say just set add n, and n equals to, we need to get the next element. So we say get next number n, and we say like try int, we need to return, by the way, return true, and then we say private int get next number int n, right? And we say int count equals to 0. Then we need to we need to go while n is greater than 0. Say count plus equals to n ten multiplied by n 10, and we need to, we say just, you know, we take here we take the first I mean the last value of like 19. I mean, like, we take like 9, you know, and we say like we take like 9, because that means that we take the last element, you know, here in this like kind of like, you know, and we multiply 9 by 9, and we set this value to our count. Then to get the next element, like 1, we need to say n divide equals by 10, and then we take this element multiplied by this element, and we add up this you know, kind of like this and this values, and we get like count, then the new number, we get the new number here, and we return count. That's it. So we just use set to overcome the loop, which goes endlessly in a cycle, you know, kind of like if the set like contains n, then there is a loop. Otherwise, when we get to this point when n equals to 1, we kind of like break this loop and return true. So that's it. Let's submit. There we go. That's good.